Okay. Ready, Akhil?
Yep, and get started.
Okay, yeah, we'll get started.
Cool.
Just real quick, I'll give a quick shout out to my team, which is hosting this. Tori, um, Jason, you want to just invite everyone to follow us on the website?
Sure. I'll drop our website in the chat. I did get the .com, so it's not that hard to find, but we'd love it if you'd if you're interested, sign up for the email updates. We're gonna ship we're gonna do an update weekly of a cool feature that we've shipped. So you should see some interesting use of AI in those features that we're hoping to push on a weekly basis now that we are live with our first beta user, which is pretty exciting. So thanks for joining the Tori Tech Talk. I'll let Julian take it from here.
Cool, thanks. And then and then our speaker today is Akhil. Akhil is the CEO of PlusOne.ai. I encourage everyone to visit their website. Yeah, and Akhil, you want to just take it from here?
Yeah, happy to. Hey everyone, my name is Akhil, and I want to make a slight edit here. We did a quick little pivot about a week and a half ago. So right now, the website you see up isn't necessarily a product that we're pushing towards our users. And essentially, what we're doing instead is building an entire stack for developing LLMs, super fast and super simple for anywhere from startups all the way to enterprises. So we handle the infrastructure layer from your vector databases, different RAG strategies, one of them being CRAG. And from there, we also do multi-model serving. We have agentic architectures kind of in place, so you can kind of drag and drop, have your agents interact on API layer, and then push to production when you're ready. So we're still on a private beta, and I'd be happy to share our link to the larger group for you guys to play with it. But with that being said, I'm happy to kind of hop into the paper. Julian, do you want me to?
Yeah, I'll let you share your screen.
Sweet.
And
Happy to. Let me know when you guys have seen the screen. Cool. So this paper is about corrective RAG. And for those who are either new to the LLM space or in RAG in general, I'm happy to give a quick little refresher of what RAG is, what's the value prop, etc. So essentially, as I'm sure you guys know, LLMs are incredibly smart, right? They're trained on 70 billion parameters. If you're looking at the llama models, I guess 80 now. And then even like you have your 6-7 billion parameter models as well. And essentially what LLMs do is they inherently, just because of this vast data set, their neural networks are designed essentially to predict the next possible token. So when you chat with ChatGPT, all it's doing is referencing its internal repository information saying, hey, I predict this to be the next response. And it's passing that in token form from via NLP back to the user. Because of this large data set that these models are trained on, what we've kind of seen, and I'm sure you guys have seen as you experiment throughout various different use cases, is hallucinations. And the reason being is, these models are trained on a set of data. And then when you try to narrow that query down to specific data, let's say, you're, for the most simplest of manners, you're querying against your own product information, the LLM starts hallucinating and gives incorrect information. That leads us to the development of RAG. So it's been one of the most hotly talked about topics in the sphere of Gen AI for the past, I would say, roughly about a year now, starting with the LangChains and Llama indexes of the world. And RAG was great. And essentially what it did was it allowed you to take this arbitrary set of context like the model has and this vast information the model knows, and you're able to restrict that context based off a subset of documents that you're able to semantically retrieve with the vector database. So RAG is great, and on surface level, it solves the hallucination problem to a certain degree. But then as you start getting more granular with enterprise use cases and you start looking at more complex situations, you'll start to see that the semantic retrieval that happens within RAG starts to degrade in terms of quality. And that's ever present even in today when you start taking things into production, which is, as I'm sure you guys are all aware, one of the biggest problems that enterprises have now is, you can build all these POCs, but taking to production is difficult. And a big proponent to this is the hallucination factor that's yet to be solved, even with RAG. So that led us to the new wave, quote unquote, of additional RAG strategies. So you have your self-RAG that Julian's going to present on later. You have adaptive RAG. And what I'm going to be talking about here today is corrective. And the whole purpose here is really to improve the robustness of generation. So you can see here, I guess in the abstract, this figure doesn't do a good job of kind of talking about it, but in general RAG architecture, you basically take a query, you embed the query, and you pass it into a vector database. So the vector database is a similarity search based off the vectors of the query with the vectors of the already indexed documents. And based off the specific similarity metric, whether it be cosine, Euclidean or dot product, it's going to return a subset of documents that match your specific query parameters. These documents are then essentially used as the context for your LLM to produce a specific response. These responses, again, if you have accurate documents, are wonderful, but your generator LLM, if you have inaccurate documents, as you can see here, it sucks. And what corrective RAG tries to do is really try to pinpoint and narrow down, build something that actually enhances the accuracy of the documents it's retrieved in and of itself. So that's essentially the first part of this entire document itself. So I want to talk through how corrective RAG kind of sits in here. So this is, let me try to see if I can zoom. There we go. So this is high-level architecture diagram for corrective RAG in and of itself. So all you're really doing is you're adding another NLP model in the flow of your RAG pipeline in and of itself. So obviously you have your retrieval, right? So this retrieval is after you've embedded your query, you're able to get a set number of retrieved documents. Let's say Pinecone returns the top 10 relevant documents. It's document 1 all the way to document 10. You then pass those documents into a retrieval evaluator. So this retrieval evaluator, in this paper, what they used was Google's T5 Large, which is a text-to-text NLP transformer. And what's funny enough, and I guess I'll touch on this later, but that was a transformer that was used, and it was fine-tuned on the specific subset of documents that, or retrieval documents that they were trying to do for this specific use case. And that's another important note that I'll get to later on. So this retrieval evaluator here is then going to analyze these documents that come in and judge them for their level of accuracy with regards to a specific threshold value. This threshold value is set by the user. What the retrieval evaluator does, it takes each of these documents and assigns a specific score. And then from there, it assigns a specific confidence, being correct, ambiguous, incorrect. This is where corrective RAG is, it's still in its early stages and it's still super experimental. The correct field per se basically just requires a single document to be above the specific threshold, while the incorrect is basically you have all of the documents below the threshold. What's really, I guess, fascinating is when you get to the ambiguous case, because obviously you're going to have documents that span either above the threshold or below, but you're going to have multiple documents if you constructed a good RAG pipeline to be above that upper threshold mark for accuracy. And what this essentially means is if it's correct, it's going to go through this knowledge refinement kind of phase where essentially you take the documents, you further sub-decompose them, and then you filter to then recompose the documents once you get the substrips into what's quote unquote a little more refined knowledge base. I have personal opinions about this in terms of the level of refinement you actually need for a lot of production use cases. But I think what's more important is really to focus on knowledge searching. This is where it's very similar to self-RAG in a way, and Julian's going to touch upon this next week. But essentially what you're doing with both ambiguous and incorrect is you're doing this thing where you take this query and you're going to feed it into a subtool or a subfunction that's going to initiate a web search. And the web search is then going to, obviously, in this case, you're talking about Batman, it's going to go to Wikipedia, pull up stuff about Batman, and you're screwing that, right? So it's going to pass in a subset of information, and that's going to be, in the ambiguous case, appended back in to the existing documents that were kind of passed through that upper threshold check, to then eventually pass into your generator model. And this generator model is that final LLM query, which is then comprised of your existing knowledge base that's retrieved from RAG, and then your I guess your augmented data from your web search. So that's in the ambiguous case. The incorrect case, I think, is not necessarily super accurate. I think if you have all your documents below a certain threshold value, in my opinion, you have to go then reanalyze your overall pipeline, because you can't necessarily, for almost all use cases, just rely on a general search. But the ambiguous cases, I think, super effective, because you're essentially augmenting your existing data source with an external data source that tends to be more accurate. So that's CRAG in a nutshell. I did want to touch upon the retrieval evaluator here. And I think when I first read this paper, I was like, cool, I work with a T5 large. I want to throw OpenAI at it. And funny enough, what the researchers did was they actually used OpenAI with GPT 3.5, and they did it with few shot and just zero shot learning. And what they found is a fine-tuned T5 performed a lot better in terms of retrieval evaluation than any of the other OpenAI models, which in my opinion makes sense, right? Because OpenAI is inherently a language model. Retrieval evaluator, you're looking at scores, assigning numerical values to specific documents. And it's a fine-tuned model, so it is going to outperform your standard LLMs per se. So that's the biggest call out. That's interesting. I wonder how GPT-5 performs as a sub retrieval evaluator, but I'm sure that's going to be inherently ridiculously expensive for a lot of production use cases if you're doing an evaluation per query. But that's high level in essence what CRAG is all about. I think I'm happy to kind of open the floor up to questions, kind of things that I can retouch on. Also happy to kind of give my own opinions about this as well.
Can you cover how this affects performance, both on metrics and
Yeah, definitely. So we actually have kind of the performance metrics based off specific data sets. So I do want to say and preface that these were, let's say, fine. So that T5 is obviously fine-tuned with specific to this with this individual kind of data set that they're testing on. And you can see that baselines without retrieval, doesn't matter essentially what model you're using, are pretty bad. So this is obviously the RAG. But then when you start using more complex versions of corrective retrieval augmented generation, your overall baseline retrieval scores tend to get higher. I think this is kind of a self-explanatory analysis where it makes sense, because you're essentially having another LLM rank all of your documents and only feeding in the most relevant documents to that end result. Does that help answer your question, or do you want me to get more granular with the metrics there?
Sure. I mean, get as granular as you'd like, but do they also cover inference time? How much additional time does it take to perform CRAG versus RAG?
Yeah, they don't cover inference times. I think it's safe to say that inference times are going to be inherently larger, and also very subjective, because it highly depends on where your T5 is hosted. If you were to host it on just a general EC2, inference times are obviously going to be ridiculously large. If you host it on something like an inferential instance, where you can cut your total inference time and cost by over 60%, you're going to have a faster kind of rate of return for that specific model. But I think it's highly subjective based off the specific use case or space of the specific infrastructure that you provision for your RAG architecture. There are also other elements, right? In this case, I think their end state LLM that they're using are either Llama 2s, but if you wanted something to improve inference times, right now, Haiku is your market leader in terms of that, right? Or if you want something more open source, not sure about how Llama 3's inference times work, but I think Mistral or DBRX. One of the two are still in the lead.
And that's because a great deal of time is now being taken up by the web search itself.
Exactly. Essentially, the issue here is if you have low latency workloads, as you start inherently introducing more function calling, more tools, etc., you're inherently slowing down your overarching pipeline architecture itself, right? There are ways you can potentially optimize. I think, like any generative AI problem, I think it all boils down to data. And I think this is the biggest thing that I think is like the big takeaway from all these papers isn't necessarily, in my opinion, the architecture surrounding it. I think it's more so people understanding that generative AI problems are data problems, and people aren't necessarily focused on how can you get a good ETL pipeline to then produce the LLM with high level, um, high quality documents, as opposed to just saying, let me throw that pipeline and throw GPT-4 and have it magically solve all problems. And I think that's a big thing that we see even at the enterprise level when you talk to, enterprise customers, but also at the startup level as well, where I mean, I know a year ago, I thought GPT 3.5 was going to solve all my problems with every single one of my ideas I had. And as you start really playing around with it, you realize it's not the case. And I think this is ever so echoed. I've had a long standing thesis about this, but I'm not sure if you guys saw Altman's most recent video about GPT-5, where he said GPT-5 is going to be inherently a huge step up from 4, which is crazy to me because I think 4 was insane in terms of overall development. But he's basically said that if you're trying to compete with the FM providers, you will lose. And if you do not have a data moat, you will lose. And I think these papers, along with the general trend of how generative AI is progressing and how fast it's progressing, continues to show that you need to have a different moat that's not tied to your data providers, or sorry, to your LLM providers. And instead, you should be really focused on building a quality. But that's my long-winded rant.
Fantastic. Anyone have any questions?
Yeah. Can you scroll back up to the diagram?
Yeah, for sure.
So in the ambiguous and incorrect case, it's pulling information in from an internet search. Is it actually writing that back to the vector DB and like updating the source documents? Or is it just inserting the corrected version into the final prompt?
Yeah, it's just inserting the corrected version back into the final prompt. It's inherently another tool call. That's the way I look at it. So you can do this now natively with almost any model, I think, has function calling at this point. The only difference here is you're adding an extra check for your runtime. I don't think the incorrect is something people should even build for, because I think if you're having everything below a certain threshold value, you need to go back and look at your data. But I think the ambiguous case is interesting because now you can augment certain use cases, obviously not all, because if you, for example, let's say you're building an automation tool for AWS infrastructure, you have a fine-tuned model, you have a RAG pipeline, you hit the ambiguous case. If you do a web search on EC2, you're kind of screwed, right? So you're going to be pulling in so much information. So I think there's a layer of optimization you can do over search as well, and I think that we'll start to see that. But I think the second aspect is understanding where this knowledge searching really kind of lives. Obviously, there's other ways. It doesn't necessarily have to be a web search, right? You can do a tool search on even further opening up your entire internal production repository. Let's say you have a Notion plugin that's tied in with your function calling. You can then go in and have a further subset of information that's more relevant to your specific use case. So my larger point is web search is great, but I think there's ways to optimize that.
I have a question actually around that, because I feel like this paper doesn't provide, like, it seems like, right, most of the improvement in the accuracy actually seems to be from this web search, right? Because previously with just RAG and CRAG and stuff, it's not working. So why not compare against, like, basically a much simpler solution would just be to do a web search for each case, and that should be the baseline that they're really comparing against. Because it's like the way I'm thinking about it, right? If I have to implement this, I have to fine tune T5. I have to come up with all these metrics. I need to do all this when really all it's telling me is like, oh, if I actually do a web search with the user's query, that's where like most of that extra accuracy is coming from. So to me, honestly, this paper seems like just a ton of complexity added on top of complexity that already exists, and just not enough baselines in there to actually like really be useful. I also haven't looked at implementing this, but like I just feel like I, as someone who would have to maintain it and explain why did it give the wrong answer, it's going to be pretty hard to do. Is it like, oh, it's the T5 or it's this or it's that, or I don't know. And then the expense of having to maintain this is like, yeah, I don't know. Those are my thoughts. I don't know, like, if you have any like other critiques of the paper, but yeah, to me it seemed like, I guess seems like most of the improvement is coming actually from the web search, right?
Yeah, no, I totally agree. And for the most part, I agree. I think 90% I'm with you. I will say where the value is that retrieval value, because inherently everyone has a RAG pipeline. You're going to retrieve documents. If you are just doing the reason why you can't compare a base, let's say OpenAI to function calling as opposed to a RAG pipeline is when you go through the query in and of itself, if you're querying against very proprietary data, if you just do a web search, it's not going to yield anything significant for you. So, for example, one of our previous use cases was we deal with specific product documentation that's locked down within someone's Notion. Doing a general web search isn't going to really yield us any or yield the LLM any relevant information for a specific user's use case, which is why a RAG pipeline is built, right? And
Yeah.
inherently, when your point exactly, when you do a web search, you're obviously going to get some level better with specific results. But I think what this paper fails to really look at is how vast and expansive everyone's use case is, and this can't be generalized across the board. It's not like if you implement corrective RAG into your pipeline today, it's going to be end all be all fix. The same way a year ago, if you were to implement RAG, it's not going to be end all be all fix. And I think what my whole takeaway from this is, again, shifting the conversation away from all this infrastructure piece and really having users, founders, customers, whatever they may be, focus on building a good data pipeline. I think these techniques are great. I think if you're Google or if you're Amazon or Azure, you can implement a retrieval value. If you're a startup that's cash strapped and trying to find their first customer, fine tuning a T5, throwing on an EC2 is not going to be your solution. I think there are better ways around it. I think high level, the way people are starting to think about really augmenting or how to augment your existing RAG pipeline is in the correct direction. Is this the perfect solution? I definitely don't think so, but I think the conversation is starting to move into more data, which I do appreciate.
I'm with you on that. I think, yeah, the data is definitely the most important piece, but I almost feel like, yeah, just doing some kind of similarity search on whatever documents you have and bringing up the closest document to the query that you do have. Like, it's just about how much are you willing to potentially give that information to the user and how much complexity do you want to introduce? And I don't know, I think that, yeah, I feel like I see a ton of papers that are kind of like, let's try to add another LLM. Like, we have a problem, so let's with this LLM, so let's solve it with another LLM. And to me, that's just like a problem squared, you know? So yeah, I feel like just the baselines even that that are comparing against are like, I guess it'd be interesting to know like what information are they using that it's a mix of web search and proprietary, and how does that work? There's just like, I feel like I have more questions than answers in this paper, essentially.
Yeah, no, I agree. I think the way I view like a lot of these papers is understanding high level where the direction of the generative AI atmosphere and landscape is moving towards. And not necessarily because Gen AI is a black box and it moves so fast, right? Like what's relevant like RAG was super relevant last year. At this point, if you were to have a general RAG pipeline for most of our unique use cases, it's just not going to work. I mean, you have one-offs where if you're just querying against a certain subset of documentation, you're creating a chatbot against that documentation. Sure, it'll probably work. But a lot of our use cases are a lot more nuanced. And I think that's the general trend, right? Things are moving so fast. CRAG is probably going to get outdated once a FM provider natively integrates something similar. I also think once you start looking at agent-based chunking, if you guys are familiar, and that opens up a slew of other topics that we could discuss, but agent-based chunking is basically when you have, to your point, you throw an LLM and you basically say, cool, you do well with HTML and div data. I want you to chunk this for me in the most correct way possible. And one of the ways that you can optimize RAG pipelines, obviously, is through chunking. So essentially, if you have an LLM that's trained on how to properly chunk data and still hold semantic similarity, you then inherently increase the quality of the true documents. But to your point, that's basically throwing an LLM into another problem set and having it solve for it. But
Yeah, the way I feel, I guess, is like someone who's actually like, work, like, I guess would be worried about, it depends on your use case, right? But I just feel like a lot of time, like when something goes wrong, how do you understand why it went wrong, right? That becomes my question. So like, how do I fix stuff basically when it goes wrong? What was the cause? And is it even reproducible in a lot of these cases? Because that, like, if your feedback loop for having to improve is you have to retrain T5 and it costs like however much money and however much time, you just can't make progress fast enough. Like I think if you had all the resources in the world to train all the models in the world, which it seems like some of these companies really do, then I would say have fun. But yeah, it's like realistically, like it's just I just feel like debugging code that's just not doing anything with an LLM is hard enough, and I can't imagine trying to figure out like why did my bot give this discount to my customer even though it wasn't like in the stack. Like how do I like which part is do I have to fix there? It's like I don't know. But I feel like I'm just trying to be the devil's advocate here. I think it really depends on if you're trying to build a Google competitor, maybe this is the way to do it. Like that's not what I'm trying to do. I'm not trying to answer every question. So like I think that I'm just trying to be a contrarian here a little bit and like keep the conversation interesting. But I think like all this stuff, like you said, like knowing what the direction people are moving in is like very useful and very interesting.
yeah, no, I totally agree. I think for majority of startup use cases, I don't think CRAG is a financially smart way of going about it. But yeah, no, I agree with you. I think the larger theme of it being a data problem, and I think I've talked to a couple of founders here who essentially have really big data problem exercises, and I'm thinking of one in particular where if they can solve for that, the rest is inherently easier. And I think as more and more people start to think that way, we'll just get higher quality LLMs and retrieval and such. And I feel like it's one of those things where it's kind of pushed down via like your large cloud providers, your infrastructure providers, where it's like you have this fancy new LLM, like for example, Llama 3 came out, blew DBRX and Mistral 7 out of the water, and everyone's like, that's going to be the next thing that solves all my problems. And again, people just aren't asking the right questions when it comes to any Gen AI solution per se. So I'm with you there.
Yeah, I think I agree. I'm a huge data guy. I think like LLMs, maybe they work as a like layer on top, but yeah, you're completely right. If like you don't have if you don't have the right information, garbage in, garbage out.
Exactly.
Yeah.
It's also from a business perspective, it's probably the only lasting node as well.
Yeah.
Any more questions?
Yeah, I got a question. I don't want to draw the wrath of Red by introducing more complexity to this, but this diagram stops at the point of, like, this is just the context that goes to the final call, the LLM. So what about like a layer on the output of that? Is that something that has been explored or that you guys have read about? Like, it could have the right context and still spit out the wrong answer. You know, like there's still a hallucination that could occur in the generation step that isn't being checked and caught. So I'm curious what people think about that.
Yeah, I guess I can start, but I agree. I think that's where you have to have very strict and rigid guardrails in place. I think for, you know, the longest time it's just optimized for prompt engineering, but I think as models get better and as we start training on larger data sets, I think inherently we're going to introduce hallucinations and complications on every single stage. I think on a high level, like Nemo does a good job of having some level of abstraction from, or having some level of control from both the input and also the output layer for on a guardrails perspective. And then I think a lot of it just at this moment boils down to LLM ops and observability. I think inherently everyone understands that it's still experimental, but being able to track your, specific, because to RG's point, RG, sorry, I can't see your name on here.
Fred. It's Fred.
And what I like, to his point, there's so many layers of complexities and so many places where you can have potential failure points, where it's inherently a large observability exercise of you tracking down, individual prompts, responses, your individual like training phenomenons, et cetera. And I don't necessarily think observability has been solved yet. And we have big players like Arise, Comet ML, et cetera, that have started to do a good job and train towards that individual point. But I don't think there's a way of not necessarily quantifying, but I think in my opinion, what's more important is quantifying your overall observability metrics, at least from a implementation perspective. So I don't have a good answer for that. I think from what I'm reading now, it's morally just make sure you have a good LM ops pipeline and make sure your prompt engineering and your guardrails are properly in place.
My answer why, even though I'm sitting right next to you, is basically that truth is ambiguous, and you can't really just like, even this idea of correct, ambiguous, and incorrect. It's, the same sentence can be interpreted different ways by different people, and so basically, like, I think it's kind of like you have to have a good like idea of what truth is. If it's really simple, right? If you're just looking at dates in history or something like that, it's easy to define. But like things get like much more nuanced, and there isn't really like a true or false value all the time. Like, so an LLM can't solve that problem, if a human can't. Yeah.
AGI will save the world, according to Altman. So one day.
Well,
So, I mean,
where? Oh, God. Sorry, Bob.
no worries. No, I mean, my thought on it, Wyatt, just taking a page out of what we see other people do, like, generally I kind of in a similar contrarian point of view, which, I mean, it's kind of crazy because we're building something that's really based in AI, but I'm trying to minimize the role of AI as much as I possibly can, because the moment it spits anything out, and I don't like, I was talking to my friend who built the AI platform at Compass, and then he moved on to doing some AI stuff at Apple, and he was like, be concerned of snake oil salesmen that say that it's going to solve everything for you, because I'm working on it on the other side, and I'll tell you, it will not do that. But the thing that I see, in, like, to Red's point of, how do you determine correctness? Like, even if you look at the example of what OpenAI does, like every once in a while they like ask you like, hey, here are a couple of different options, like which one is better? I feel like it's probably like the only way to like introduce like an element of, okay, I don't know exactly how this thing is supposed to be interpreted, so I'll give you a couple of options. We're kind of thinking about that on our end, if we do something similar or not. But that's the only thing that I think about when I think about like correctness. It's like sometimes you don't know exactly what's correct. You're facing that problem literally at every step. So I think it's about recommendations and giving like I think we're moving to the approach of like confidence scores, which is kind of the advice that I got from my friend is like, well, you know, you should probably qualify, never say like that's definitely like you put it out there and it says like, you know, this is absolutely missing. That's a definitive statement. But if you qualify it with like, okay, this is why we think that one, but two, this is how confident we are in the assessment that we made, then I think it starts to get more like recommendation based instead of like, you know, declarative. This is exactly what's happening. At least that's how we're thinking about the correctness portion.
Yeah, and at risk of maybe taking the least advanced math of anybody on this call and opining, building on what Red was saying, like, it seems to me that your baseline isn't an LLM and its prediction, you know, predicting the next word via ingestion of like a ton of text. Like a web search hooked up to a logistic regression is kind of your baseline question here. If what you're doing is taking information from the web and trying to have a probabilistic, you know, answer for what a single objective truth is, which is, you know, not dissimilar from what Buff was just talking about. But what I'd ask is like, when you feed it back into an LLM, it almost seems like the experiment design is kind of what's disappointing about what they're doing here. Because if you're feeding it back into LLM, you know, you could ask more complex questions at like the intersection of two things, right? Or multi-step questions. And it seems to me that that's when RAG will start to like really shine versus, you know, kind of deterministic or like objective truth probabilistic questions, right? Where there's a second step that needs to happen and then maybe a third step, or you're pulling inferences from two areas. I struggle with like a concrete example from what we're working on, but you know, when we're looking at very like small data sets in the grand scheme of things, you know, asking questions like based on email history that we've scraped, you know, would we accept this dog at the hotel? It takes first a question about pet policy and then an interpretation of the size of the dog, right? So something like that is significantly improved by kind of retrieval augmented generation as opposed to more simple forms of regression or probabilistic analysis. So anyway, that's just my observation that maybe like its utility becomes more exciting in when you add complexity because you're asking an LLM to do either multiple steps or look at inferences between two things. Has anybody like seen anything related to that? Or am I thinking about it wrong? Like what's
I guess I guess the way I think about it is and it may not be like a direct answer to your question, but like there's two things, right? I think number one is I think that as far as papers like go in the machine learning community, right, we keep just trying to like throw the same like hammer at like if you only have a hammer, every problem looks like a nail kind of thing, right? And no one's really taking a step back and thinking like, what's going to be the way to actually solve this, right? LLMs hallucinate, right? They're gonna like, it's going to be hard to get them to get the pet policy right every time, especially when the person is like, oh, is it okay if I just bring the pet when I check in and leave it in the lobby and then my husband takes it later, blah, blah, blah. And then it's like, in the happy path, it's really easy to imagine it going well, right? But then the space you're working in of possibilities is so large that you're going to wind up not going down the happy path sometimes. And like figuring out exactly what that looks like is just not like super easy because you're dealing with an object, this LLM, that is so large and hard to like manipulate and work with that it's actually like you're kind of stuck. Like you're like, okay, now I need to just patch on top. And so like there might be ways to do it. And like if you're able to structure things well enough, like if you get people to really fill out stuff and you know the limitations of the like personally what I would feel more comfortable with is just like an LLM that says, honestly, I don't know. Let me put you in touch with customer support. Like a lot of the time. Honestly, I'm just like, as a user, you know, it's just like, because it like there's going to be cases where it's not going to know. I'm thinking about my own like family's agritourism, and it's very like ad hoc type stuff, and like there's all these like trails around, and it's documented in brochures, and it's stuff where it's like there's an effort to put all of this information in one place in the first place, right? So that it is accessible. And yeah, like I think that goes back to the data thing that Akhil was bringing up, which is always like the main point that everything goes back to. But I think that like in practice, you got to see what works for you, right? Like it could just be that tweaking the user prompt makes your GPT like amazing at your use case, and it's like that simple. But I think once you get down the rabbit hole of like every possible use case that your customers have, there's going to be some weird edge cases, and you're going to have to like, you're going to be scratching your head, because it's not like you can go in and like change one of the parameters in the model and fix everything.
I would kind of argue the point that, you know, if you can solve 80% of the problems and kind of, you know, if 80% of customers have a similar set of questions that, you know, within the realm of normalcy, and then, you know, you have 1% that are intentionally trying to prompt inject or, you know, mess up the system, and maybe some questions are just difficult. You know, maybe some tools like, you know, what Illuminate's building, you know, maybe able to classify these requests separately and you know, perform well on the 80% case, maybe grow that over time, and maybe just focusing on the core set of good experiences is enough for the moment, and then
So
expanding that.
I completely agree. Like the happy path could be very wide, right? Like the happy path could be 90% of your cases. The thing I'm telling you is like it's not always going to be the happy path, right? Like you've been on calls that go weirdly with an old person who just called because they were lonely or something. I don't know. And like it can happen, right? It's again, but so it's like
And then I
you
think,
got, and
and
then
then
yeah,
if you
maybe.
can identify that up front, then that solves a lot of the problem. Do you think
I
that's
Yeah.
achievable?
I, I kind of have some thoughts here, and it
Yeah,
kind
please.
of, I don't know, a different framing of the same thing, I guess. Like, so in simple, in layman's term, I think Red's point is that like, okay, there are cases that it's gonna fail. It's undeniable. It's the same as software and everything else, right? And then, Julian, I think your point is like, okay, well, if we solve for a majority of cases, which could be pretty wide, 80%.
While also identifying the
Exactly.
like the
Exactly.
outliers, yeah.
Yeah, like I think that the key statement is like the identifying of outlier cases. That is probably the most important thing. Is like, and I think it is pretty possible, but I think it is, I don't want to say dangerous, but like it's something that's a very important asterisk. Is like identifying itself may be very like a lot of data work, like being able to say like, okay, it failed in this case, and then how many more cases does that unlock for me by trying to identify that case. The way I look at it, like LLM, is like if you give it, it makes a bunch of decisions for you, right? But it's not supposed to be. You shouldn't trust it as like this overall decision maker. So if you consider the decision space of your problem that you're trying to solve, like how many different decisions could there possibly be? And if you relegate that as like, okay, I'm just going to hand that off to an LLM, if the decision space is huge, so is the space for it to hallucinate. So it's like every time you do this identification process, that's a bit, it's like an inflection point of like, I'm taking a decision away from the decision space, which minimizes the decision space for like that class of problems. So if I identify like, oh, it's hallucinating when there's an old person calling me because they're lonely, well, you've identified and made a decision about that case, and you've minimized the decision space of how you need to solve like that class of problems. But my point is like it's kind of the same. Like I said, it's just a reframing of what you guys are saying. But that's the way I think about it, and I think that it's the tree. Like you ultimately end up like what you're doing as you identify them is you're making decisions and taking them away from the LLM. Like that is inherently what's happening, and like you will ultimately get to a certain level of having made decisions in your own decision tree and you're hoping the LLM can take away complexity at the lower and lower realms. So where it's like its decision space is narrow enough that it can make good decisions based on how it's trained. And that's where, like, fine tuning and training like specific prompts, models, whatever you want to do, like when you can identify enough of the different inflection points where it fails as a general purpose decision making machine, like that's where I think you start to get really high quality results. In our case, we basically have eaten shit from like the very beginning because there's so many decisions we have to make, that it's been pretty unreliable for us to just pass generic prompts. So like we just know we're like at the top level, we're just benchmarking what is what is going on, like how are we doing at the top level, and we're doing pretty poorly. So we're trying to take the next layer of decisions away and identify stuff related to the problem, to the data set that we have, and say, okay, what is the next thing we can identify to classify as how we can break the problem into another set of subproblems, then continue on and see how that improves our results. But my point is that you can ultimately end up building a bunch of decision trees without recognizing that this is exactly what you're doing. Anyways, those are my 2 cents. And yes, I do love decision trees. I love trees, Akhil. The whole life is trees now. Anyways, sorry, that was my rant.
Yeah, we're getting towards the end of time, so maybe we'll start wrapping up. Let me just give a quick shout out for the events that are coming up next. So I'm presenting next week, Self-Rag. The paper is here, and then the week after that, Peter Turlicki is a PhD and senior data science manager at QVC. He's going to present a paper. He'll get back to me pretty soon about what he'll be presenting. Encourage everyone else to get on the rotation here. And Akhil, do you want to use any time to talk about what you're working on at PlusOne?
Sure. I think I talked about it before. Unfortunately, we don't have a demo right now. My co-founder is pushing out some code as we speak. But yeah, essentially what we're trying to do is minimize the complexities of building out RAG pipelines, building out architectures. I think I mentioned at the beginning, we are that middleware tool, and we're trying to make it low code and scalable, which is an oxymoron to say the least. But yeah, so anything from your infrastructure management, regards to your vector databases. Right now we partner with Quadrant, and then we also offer Pinecone because everyone loves Pinecone, for better or for worse. And then we also offer a plethora, that's what we like to say, of models that whether it be open source, you want to host them on specific, instance types, we're cloud agnostic, so Azure, GCP, AWS. Or if you just want to use a standard API providers, we handle all of that. We have e-commerce based solutions, but also solutions for individuals that just want to leverage a single point of entry via an API. So happy to kind of share a private beta link when my co-founders are pushing code, but that's in essence what we're trying to do.
Okay, excellent. So that concludes our talk. Have an amazing week, everyone.
I got a question before we go.
Please, yeah.
Would people maybe be able to be interested in setting up a little group just to send papers in that they find interesting?
Oh, absolutely. Yeah.
I think that would be great because like I'll go on archive and like just search like LLM and then and there's just like so much stuff coming out. I think it would be helpful to have some.
Oh, 1000%. Yeah. I just want to make sure it's open to the public and not just our community. So
do you want to set up a Slack channel then at Tori that like is a
yeah,
public Slack channel and people
let's
can drop
talk
it in there?
offline about this.
Okay.
Awesome. But yeah, fantastic suggestion. Thanks.
Thanks for setting this up. This was really interesting.
Awesome.
Yeah, this is great.
Yeah, this was fun.
Have an amazing week, guys.
Thanks,
Take care,
everyone.
everyone.
Take care.